Now consider a partition of the sample space. This is the sample space, and let's say we have a partition. And remember what partition is. The subsets in the partition are all disjoint, and when you unite them, you get the sample space here. Okay, this is what we call a partition. So S equals the union of all of these subsets, and pairwise they are all disjoint. Now consider an event A in this sample space S. You see this event A also has a partition with respect to this partition consisting of B's. And for instance, take this one, this subset here. This is A intersection B1. And this here, A intersection B2. A intersection B3 is equal to B3. A intersection B4, A intersection B5, B6, etc. You get the idea. Okay, so you see these intersections, they form a partition of the event A, because you see when you unite them, you get event A, and they are pairwise disjoint. Now based on this, when you have a partition on the sample space S, for any event A, I can write A as the union of these smaller partitions. And since they are all disjoint, I can invoke the third axiom to write the probability of A as the sum of the probabilities of these subsets. And then I can apply the definition of conditional probability to write the probability of this intersection as this expression here, a conditional probability times the probability of each partition. Okay, so this is what we call the law of total probability, and it's extremely useful. Let me give you an example. Suppose we have 3 urns with the following content. 3 urns. Okay, in number 1, I have 2 red balls, 3 blue balls, and 5 white balls. In number 2, I have 5 reds, 1 blue, 4 whites, and in number 3, I have 3 reds, 7 blacks. I throw a fair die. If the outcome is 1 or 2, I pick a ball from urn number 1. If the outcome is 3, I pick a ball from urn number 2. Otherwise, I pick from number 3. What is the probability of picking a black ball, or a red ball, or a blue, or a white? So, probability of, let's do red. Probability of red. What is the probability of red? Now, the problem here is I cannot write this directly because I do not know which urn I'm going to use. That's the issue here. So what I'm going to do is I'm going to condition the outcome red on the outcome of the die, or rather the urn I'm going to use. Because using urn number 1 or urn number 2 or urn number 3 is essentially a partition, or if you consider the die, the outcome 1, 2, and the outcome 3, and the outcome 4, 5, 6, those 3 form a partition. So I'm going to write this as probability red given die is 1 or 2 times probability of die 1 or 2 plus probability of red given die 3 times probability of die 3 plus probability of red given 4, 5, 6 times probability 4, 5, 6. Now I can write this directly because consider this. If the die is 1 or 2, I pick a ball from urn number 1. So now I can write this probability because I know that I'm going to use urn number 1, and to select a red out of this has what? 2 divided by 10. So this is 2 divided by 10 multiplied by probability that the die outcome is 1 or 2, that is 2 divided by 6. Plus this one. When the die outcome is 3, I use urn number 2. So this is my sample space now. And the probability of selecting a red is 5 divided by 10 times probability of a 3 when I throw the die, so that is 1 over 6, plus finally I have this. In this case, I'm using error number 3, so the probability of red is 3 divided by 10 times probability of 4, 5, 6, that is 3 over 6. So this is 4 plus 5, 9, plus 9, 18, divided by 60. So this is the probability that I pick a red under this random experiment. You can do the others, the black, blue, white, etc. Very similarly. Now, if I pick a red ball, now this question is upside down. If I pick a red ball, what is the probability that the die outcome was 3? Okay, so as I said, we have computed the probability of red, and we can write, for instance, probability of red given die 3. This I can write because when the outcome is 3, I pick a ball from error number 2, so this is 5 over 10. But the question asks, what is the probability that the die outcome was 3 given the ball outcome is red? It's the other way around. So how am I going to solve this? Using Bayes' rule. Since we know that the probability of A given B times probability of B is equal to the probability of intersection, I can write it the other way around. Probability of B given A times probability of A. So from probability of A given B, I can obtain probability of B given A and vice versa, and the expressions are given here. Okay, so how are we going to solve this question? What is the probability that the die outcome was 3 given I pick a red? Now this is equal to probability of red given die 3 times probability of die 3 divided by the condition here, probability red. Now fortunately I have computed this already, so that is 18 by 60. And this one, probability of red given the die outcome is 3, in which case I use error number 2, so that is 5 over 10. And this is die outcome is, the die outcome 3 has 1 over 6 probability. So essentially this is 5 over 60 divided by 18 over 60. So the answer is 5 over 18.